Namaskar and welcome back to Aviation Avi, go where you feel the most alive. In today's video, we'll be looking at runway physical characteristics that are associated with the runway strip and the runway and safety area in this part 3 of the video. So without any delay, let's get started. In this series on physical characteristics, we will be talking about the characteristics that are required for a runway, a taxiway, a apron, the strip, shoulder, RESA, clearway, and the stopway. We have already discussed about the runway physical characteristics, the length, the width of the runway, the associated shoulders, the physical characteristics associated with the runway turn pad. Now, in this video, we will talk about the RESA and the runway strip. To start with, let us look at the runway strip. It includes the runway and the associated stopway. It is the area that is provided around the runway that will help in order to prevent the damage to an aircraft in case it overruns the runway, and also to protect the aircraft from damage during takeoff or landing. There are specified dimensions that should be provided for a runway strip. It should extend before the threshold and beyond the end of a runway to a distance of at least 60 meters when the code number of the runway is 2, 3 or 4. Further, 60 meters when the code number is 1 for a instrument runway and 30 meters when the code number is 1 for a non-instrument runway. So what we understood is for a code 2, 3 or 4 runway, this distance from the threshold or from the end of the runway, this distance provided should be of 60 meters. The width of the runway strip, including a precision approach and a non-precision approach runway, shall where practicable extend laterally to a distance of 140 meters where the code number is 3 or 4. So from the center line of the runway, it should extend to a distance of 140 meters when the code number is 3 or 4. So we have understood what are the dimensions of a runway strip. The objective of a runway strip is to prevent the damage to an aircraft when it is running off the runway and to protect an aircraft during takeoff or landing. So in order to protect the aircraft in case it is overrunning, this runway strip area shall be clear from any obstacles. And how is it done? There is a requirement that no fixed object other than the visual aids required for air navigation and those required for aircraft safety purposes. For example, the PAPI, the runway lights, ILS that are required to be sighted on the runway shall meet the frangibility requirement. So other than these, nothing shall be permitted within the runway strip within a distance of 77.5 meters from the center line for a precision approach category 123 runway when the runway is code 4F. Further 60 meters from the center line for a precision approach runway category 123 when the code number is 3 or 4. Basically what you can understand is from the center line of the runway to a distance of 60 meters when the code number of the runway is 3 or 4 and the runway is a precision approach runway. In that case, nothing can be present within the 60 meters. No fixed object is allowed unless it is a requirement to have them within the runway strip and it is provided for the safety of aircraft operations and meets the frangibility criteria. Further, we have talked about the fixed object now. No mobile object shall be permitted on this part of the runway strip during the use of the runway for takeoff or landing. Now, the runway strip that is provided, it should be graded. The grading prevents further damage to an aircraft when the aircraft is running off the runway. Now, the portion of the runway strip for an instrument runway, which includes both precision and non-precision approach runway, with a distance of at least 75 meters for a code number 3 or 4. Imagine this is a code 3 or 4 runway. So this graded portion of the runway strip should extend to a distance of 75 meters from the center line. For this from the center line and also the portion of the extended center line. Now, for a precision approach runway, this distance of 75 may be increased to 105 from a distance of 150 meters from the runway end. This width of 75 meters gradually increases to 105 meters. This is a recommendation in order to enhance safety of aircraft operations in case the aircraft runs off the runway. Further, the surface of that portion of the strip that abuts the runway, the shoulder or the stopway, you see this is the portion of the runway that abuts the strip near the shoulder or the stopway. This shall be flush in order to prevent any damage to an aircraft. Further, That portion of the runway strip, at least 30 meters before the start of the runway, shall be prepared against blast erosion in order to protect a landing aircraft from damage of an exposed edge. So you see this distance of 30 meters should again be prepared against blast erosion in order to ensure safety of a landing aircraft. Now that we have understood the dimensions of runway strip, let us look at the slopes. The slope in this direction towards the length of the runway strip is called the longitudinal slope. So for a code 4 runway, it shall be not exceeding 1.5% and it shall not exceed 1.85% when the code number is 3. You see, in this direction, the slope shall not exceed 1.5%. Further, longitudinal slope changes on that portion of the strip to be graded shall be gradual as practicable, and abrupt changes or sudden reversal of the slope shall be avoided. We discussed that a distance of 60 meter or 75 meter as applicable based on the code of the runway shall be graded. So any abrupt changes in those portion of the strip, any abrupt changes in the slopes of that portion of the strip shall be avoided. Now let us look at the transverse slope. Slope that is in this direction for the runway strip that will primarily aid in prevention of accumulation of water within the runway strip. So this slope shall not exceed 2.5% when the code number is 3 and 4. Except that to facilitate drainage, the slope for the first 3 meters outward from the runway shoulder or stopway edge. You see, 3 meters from the runway edge or the runway shoulder edge. This shall be negative as measured in the direction away from the runway and may be as great as 5%. So when you see 3 meters from this runway shoulder, this can be increased from 2.5% for a code 3 or 4 runway. It can be increased to 5% in order to ensure rapid drainage of water. Further, the slope will continue to 2.5% as usual. After covering runway strip, let us look at runway end safety area, which is a shall. It shall be provided at the end of each runway strip. So you see here 60 meters from the runway end is the runway strip, and beyond that you provide the RESA, runway end safety area, for a code 3 or 4 runway and a code 1 or 2 runway when it is an instrument 1. And it should be provided when the runway end at the end of the runway strip for a code 1 or non-instrument runway. Further, a runway end safety area shall extend from the end of the runway strip to a distance of 90 meters where the code number is 3 or 4. When the code number is 3 or 4, in that case this length of the runway shall extend to a distance of 90 meters minimum. Further, this area of 90 meters can be reduced in case we are providing an arresting material that will further help in decelerating the aircraft in case the aircraft has overrun or undershot the runway. But when you are reducing the length of the RESA, the process itself requires the acceptance from the DGCA based on what kind of material you are providing, what is the level of deceleration it will provide to an aircraft. Based on these factors, you can reduce the length of RESA that you're providing at your run. Now we have seen that for a code 3 or 4 runway, the distance of the RESA shall be 90 meters. It is a requirement, but it is also recommended that this distance is increased to 240 meters for a code 3 or 4 runway, or this again recommendation of 240 can further be reduced when you're installing a further enhanced arresting system. The width. We have understood the length of the RESA. Let us look at the width. The width of the RESA shall be at least twice that of the associated runway. Now let us consider this is a 45-meter width runway. In that case, the width of the RESA shall be at least 90 meters. Object on the RESA. As we know, the purpose of the RESA is to prevent damage to an aircraft in case of an undershoot or overrun from the runway. So any object that is situated on the RESA which may endanger the aircraft operation should be regarded as an obstacle and should be removed as far as practicable. A RESA shall be provided as a clear and graded area for aeroplanes which the runway is intended to serve in the event of an aeroplane undershooting or overrunning a runway. So it is evident that in order to fulfill this purpose, you see here, the area of the RESA shall be clear and graded. Further, the slopes on the runway end safety area shall be such that no part of the RESA penetrates into the approach or takeoff climb surface. As we know that the RESA starts from the beginning of the runway strip, which is also the location for the start of takeoff climb surface and the approach surface. Thus, the slope of RESA shall be such that it does not penetrate into these surfaces. The longitudinal slope of the RESA shall not exceed a downward slope of 5%, and the slope changes in these RESA shall be gradual and it should not be abrupt, and slope reversal should be avoided. Further, the transverse slope on the RESA, that is the slope changes in this direction, it shall not exceed an upward or downward slope of 5%, and in case there is a differing slope it shall be as gradual as possible. Now that we have understood the dimensions and the slope, let us look at the strength of the RESA. The runway and safety area shall be prepared or constructed to reduce the risk of damage to an aeroplane undershooting or overrunning the runway, and also enhance the deceleration of the aircraft, but it shall be enough strong to in order to facilitate the movement of rescue and firefighting vehicles. Now this surface should always help in decelerating the aircraft, but it should also be strong enough to facilitate the movement of rescue and firefighting vehicles in case of emergencies. So with this part 3 of the video, we have covered the physical characteristics associated with the runway strip and the RESA, prepared by Shantanu and myself and Vesha. I hope you enjoyed this video. If you like our work, do not forget to like, share and subscribe because your support is our motivation. This is Anvesha Pal signing off. Thank you.